look at the table of values right here, we have different kinds of vehicles, and then we have their horsepower, which we're going to call X, and their fuel consumption, which we're going to call Y. So let's first create a scatter plot, and then let's take a guess of whether or not this indicates linear correlation or any correlation between the horsepower and fuel consumption of a vehicle. So let's try that right here. Okay, so our X is going to be horsepower, and our Y is going to be fuel consumption. Okay, and our X has to go up to almost 300. So let's go 51, 52, 53. Okay, so 50, 100, 150, 200, 250, 300. Okay, and our fuel consumption is just going to go up to 24. So let's go 1, 2, 3, 4, 5, 6. Yeah, let's go 4, 8, 12, 16, 20, 24. Okay, so we have 105, 6.7. So we just have to 105, 6.7. 170, 23. 170, 23.5. 124, almost 6. 124, almost 6. 17, 3.4. That's really low. 17. This is 25, so 17, 3.4. And then almost 300, 8.4. So almost 300, 8.4. So to me, this, except for this number right here, if we just took a look at these numbers and we did not include this one, let's see what kind of car that is. A minivan. 170, 23.5. Okay, if we ignore the minivan, I would say that there's a positive correlation and it's probably either strong or moderate. However, with this is probably going to be called something called an outlier, and we're going to get into that, where something just doesn't fall within like the rest of the data. So possibly there's like either a weak or almost no correlation between these data. So let's actually solve this by solving the correlation coefficient and the covariance. So let's fill these in first. So let's go XY, again, that's 105 times 6.7. I get 703.5. Okay, 170 times 23.5. I get 3995. 124 times 5.9. 731.6. And I'm going to pause this and fill out the rest of this chart. Okay, so I added, I multiplied all the XYs and I got these numbers, the X squareds and the Y squareds. So now I'm going to go down every single column and I'm going to add up all the numbers. So the sum of the X's, I get 712. Okay, the sum of the Y's, I get 47.9. The sum of the XY's, I get 7,974. The sum of the X squareds and Y squareds, I get 143,206. 143, 206. And I get 714.1. Okay, so now let's actually plug these into both the correlation coefficient, and then we're going to solve for the covariance as well. Okay, so here's the covariance. So S, X, Y equals, so we're going to do 1 over n minus 1. There were only 5 data points this time, so 5 minus 1. And then we're going to add up all the X minus X bars and the Y minus Y bars. So X bar, the sum of the X's is 712. So we know that 712 divided by 5 is going to give us X bar. And then Y bar, the sum of the Y's, is 47.9. And when we divide that by 5, we're going to get Y bar. So 142.4. And we have 47.9 divided by 5, 9.58. Okay, so up here, if you take a look back at all the X values here and then all the Y values here, that's what we're going to list right now. 105 minus, we're going to go 170 minus, 124 minus, 17 minus, and then 296 minus. And we're going to subtract 142.4, 142.4, 142.4, 142.4, 142.4. Okay, now the Y's. 6.7 minus 23.5 minus 5.9 minus 3.4 minus. I'm just going to write this out. Okay, here we go. So all of them, this is every single Y value, and then we're going to subtract the 9.58. So what we have right now is 1 over 4, and then we're going to multiply it by the sum of all of these. So I'm going to put 2 into my calculator at once. So first I'm going to put these 2 in my calculator. I get 107.712. So 107.712 plus, and then I'm going to put the next 2, these ones into my calculator. And I get 384.192, 384.192, and then the next one, get 122.912, 122.912. Next one I get 774.972. And for the last one I get negative 181.248. Okay, when we calculate these, let's add them all together. And I get, so 1 over 4 times 1208 and I get a total of 302.09. And that's the covariance.